December 19th, 2016, Gyrochronology. Basically, something spinning can be determined how old it is based off of how it spins and how fast it's spinning. I'll go ahead and read this out to you, see if you can make any sense of it. The entire field of gyrochronology faces issues as well in light of stellar metamorphosis. Determining the ages of stars based on the rotation rate will be flawed, as the mass is lost per the ML, or mass loss principle. And the angular momentum of the star as it cools and gravitationally collapses will remain stable, because the mass being lost will carry away the additional angular momentum needed to speed up its rotation. So in other words, it's like a figure skater. When the figure skater is spinning really fast, if she brings in her arms, she'll spin faster. But if her arms rip off, God forbid, she'll spin the same rate, and it will be like as if her arms never were pulled in to begin with. So basically, when a star is spinning, if it loses mass to solar wind and solar radiation, it's going to keep on spinning the same rotational velocity as it collapses upon itself. Basically, that's all it's saying. This means its rotation rate can remain constant as it cools and shrinks, and very old stars such as the Earth can be slower than young stars such as Jupiter, or much faster than younger stars such as the Sun. It is worthy of note for any future researcher to consider how fast an object lost its mass by determining how fast it is rotating, but interpreting the rotation will have issues not considered by establishment. The current ideas accepted of gyrochronology of Sidney A. Barnes do not take into account angular momentum loss due to the mass loss of the star, nor the complete evolutionary track of stars outside of spectroscopic surveys. Outside of spectroscopic surveys, meaning surveys of the light spectrum of the star. Obviously, they think all stars have light spectrums, so the old stars that do not have light spectrums are outside of the spectroscopic surveys, and that's exactly what stellar metamorphosis says, that as a star ages, cools, and dies, it loses its spectrum because it no longer shines from its own light. And astronomers call those planets and exoplanets, which is really unfortunate. That's one part of this talk. Look that up. It's a new field of research, and you'll be able to see how crazy it's going to be if they continue on their path. It's just going to be a wild mess if they don't correct it right now. Another idea, or two sets of ideas here, are the diminishing solar abundance principle, I guess. It is outlined in the principle of diminishing solar abundances that stars lose the lighter materials in large amounts and leave the heavier material in the central regions. This includes iron, nickel, gold, titanium, and lighter elements which have combined to form much heavier molecules. And the principle is outlined as follows. As stars evolve into rocky, differentiated worlds, the ratio of lighter elements to heavy elements diminishes considerably, meaning the older stars are going to be comprised of heavier elements and the younger ones are going to be the lighter elements, which is the complete reverse of what the Big Bang creationists want you to believe, that the majority of stars are comprised of helium and hydrogen as they're really, really old, and then the young stars have the iron and nickel and all the heavier elements, which is completely absurd. Diminishing gravitational fields. It is outlined in the principle of diminishing gravitation that stars lose mass as they evolve, therefore their gravitational fields weaken considerably. This is very, very simple, but it gets astronomers all the time because they don't know what happens to stars as they evolve. It says here, stars, as astrons evolve, the strength of their gravitational field diminishes, meaning the oldest stars will have the weakest gravitational fields. It's as simple as that, as a general rule of thumb. And the very young stars are going to have very, very strong gravitational fields. So if you have a really big gravitational field of a star, it probably means it's young. And if it's a lot weaker or intermediate, you can give an estimate of how old the star is based off of how much matter it can attract. And it's a rule of thumb, so it's not set in stone. Obviously, there are going to be some overlaps with other stars, but generally speaking, it's basically true. All right, take it easy, y'all.